Let's get started, guys. We are working on integration over general regions. They kind of fall into three very rough categories. And the first ones are the easiest. So I'm going to do an example of that. And that's where the limits of integration are given. So you're told x goes from 1 to 7 and y goes from x to 42, whatever it might be. And you integrate it. Second one is that you're told what the region is and you have to create it. And I think when we come to those questions, I'm going to use Desmos because I think it's helpful to visualize it. If it's a really simple situation, I'll just draw it on paper. If it's something that might require a little bit more work, I would use Desmos. And essentially here, you're told some kind of restriction on what the X's and Y's have to be. And from that, you have to generate the limits of integration. And then the third one ends up being, I'm just calling it a catch-all phrase for problems. So they give you a question where it's going to be a double integral, but it might not be that clear what the limits of integration are, or even what the f of xy is, right? So that one I'm going to call a problem ones. So I'm going to jump right in, and hopefully I haven't picked this guy before. Who knows? We're going to choose, what are we going to choose? I remember doing that one, so I don't think I should do that one. I'll just make my own up. Right, suppose you're given x equals 1 to x equals 2 and y equals sine x to y equals cosine x. And the function that you're being asked to do it with is, try to pick something that's not too horrendous. Is x, xy. Nothing too bad about that. Now, when you're doing a double integral, these two guys here, right, the limits of integration on the outside integral have to be numbers. If you ever have a situation where there's a variable, you know, x is y or x is sine y, you've screwed up somewhere, try and figure out how to make it work. Now, in this particular case, that is our f of xy. So I'm going to do the integration with respect to y, and what do I get? I get 1/2 x y squared, evaluated at sine x and evaluated at cosine x. And then after that, we can do this one. Well, if you plug it in, you get 1/2 x cos squared x. And then you take away this guy. So you're going to take away 1/2 x sine squared x, which is fine. So it's integral from x equals 1 to x equals 2. And this is the guy you're going to integrate. Now, when you get to the last integral, this thing is a Calc 2 question. It's how do you integrate a variable with respect to x in this case? It's a Calc 2 question. And that means you're going to have to go through your little shopping list of how you integrate things. This particular one has trig in it. So what my brain is saying is that I'm going to pull out the 1/2 x. And you know, what you get here could be all sorts of things, but that's what I'm doing here. And then I'm going to say, I know what cos squared x take away sine squared x is, because I'm good at remembering identities. Well, I'm not that good at remembering them, but I've done them for 40 years, so most of them are in my head now. What is cos squared x minus sine squared x equal to? And it's not 1. That's what sine squared plus cos squared is.
Would this be like a cosine 2x or
Yeah, it is
somewhere in
indeed.
that vein?
You are right. Your first thought was the right one. Now, would you agree that that's an easier integral than the one we had a minute ago? And that's one of the strategies that you use when you integrate from Calc 2. Now, does anybody know what technique you use to integrate this fella?
That looks like it would be our good friend integration by parts, because you can't really do a pretty USAB.
Correct. And that makes this the F and that the G, and off you go and you get your answer. Now, if the WebAssign wants the answer to 2 decimal places, that's great because you can do that, you know, without any trouble. if it doesn't mention decimal places, it does mean that your answer to this might have weird stuff like the cosine of 4 minus 2 times the sine of 4, right? It's going to have things like that in it, and that's fine. So you remember, if there is no mention of rounding off to 2 decimal places, you give the exact value, even if that exact value looks really weird. You know, nobody would normally say a half cosine of 4, right? That would be not a usual thing. Of course, if it was half a cosine of a half pi, I could do better. So that would be an example of the limits of integration are given, and, you know, basically follow through. Depends what you get here, whether it's U sub, power rule, integration by parts. God forbid they ever do an X sub, because they take forever. You remember those horrible X sub ones? You don't want that. I honestly don't think there is one. I probably made sure there wasn't, but just in case one sneaked by that I missed. Now, suppose you're given a region. Now, there are an example of a region could be question 5. Actually, I've done question 5, so let me move on. Can I find one that's not? Yeah, well, I'll make up my own for that one. Suppose you're given a double integral of a function x plus y, keeping the functions nice and easy, dx, dy, and they tell you the region. And they tell you the region is all the points so that y is between 0 and 1, and x is between 0 and y squared. So if the region is written like that, you are going to be doing your integration, and you're going to have to decide x or y first. Now, looking at this restriction, what do you think I should be doing here, the first integration? Should it be y equals 0 to y equals 1, or should I be doing x equals 0 to x equals y squared? What would be the...
I would say that it would be the it would be doing dx, because then everything would be in terms of one variable, which would make life at least somewhat easier.
And that is right. Here's another clue. Whatever one has nothing but numbers is the last one you do. Now, in this case, then, it's still going to be x plus y. And actually, these are the right way around. Would you agree you're going to do x before you do y? But can you imagine a situation where you do dy, then dx? So just because it's written that way, in fact, very often, don't they just call it dA to keep it vague enough that you will have to decide yourself later? Now, in this case here, integrating with respect to x, I'm going to get 1/2 x squared plus xy, evaluated at x equals 0 to y squared. And then I'll do the integral from y equals 0 to 1 after that. Now you plug in x for y squared, you get 1/2 y squared squared plus y squared times y dy. And that becomes 1/2 y to the 4 plus a y cubed dy. Are you comfortable with where we are now? Does that seem straightforward? Right. Wouldn't this just be a power rule enough you go and do the usual finish? Sally, question.
Oh, that was a thumbs up.
Oh, a thumbs up meaning I'm with you. I like thumbs up. Good. Right. Now, suppose the region R is given like this. In fact, for some reason, they've changed the letter to D, which is fine. I can call it any letter of the alphabet you like. This is question 6. And we're being asked to do the double integral over a region D of a function, a very easy function, y dA. So keep that handy. And D is bounded, interesting word, by y equals x take away 56 and x equals y squared. what we have to do here is we have to figure out how to take this piece of information, see what the region D looks like, and set up boundaries for the X and boundaries for the Y. And that's the kind of question that lends itself to visualize. So what I'm doing right now is I'm getting Desmos set up. Okay. So I'd go into Desmos and I type in the two guys that you gave me. You told me the straight line y equals x take away 56. Whoa, and I better make that not capitals. Not that that's a big deal. And the reason I can't see it is because it's a big straight line down there. Can you see that straight line there? Finished. And the second guy was called x equals y squared. So the region they want is basically this piece here. Can you see it? Right now, I'm just doing a very baby sketch of that same thing. Not particularly accurate, but it doesn't need to be accurate. It just needs to represent the information that I want. And we have to figure out how to define this region in terms of either vertical or horizontal lines scanning through the shape. Now, if you do vertical lines scanning through this shape, do you see that by the time you get to where I am here, it's blue guy to blue guy? I don't want that. I want a blue guy to red guy. So would you agree that you have to go horizontal here? Now, horizontal means that the y value is going to go from -7. So I'm writing that in. You'll see that in a minute. And it finishes up at 64. Okay, now I'm going to return back to, well, that shouldn't be there. Go back to my piece of paper and try and show you the limits of integration based on that shape. Right, this is the shape we want, right? This is D. And I'm saying you have to either scan through the shape, right? Horizontal lines going top to bottom, or vertical lines going left and right. Yes.
64 was the X coordinate, I think.
Oh, thank you.
8 was the Y.
Thank you. I see it now that you mentioned it. Right. So I'm looking at this shape and I'm scanning it this way, right? Would you agree that if you scan this way, you go from one side to the other? If you try and do it vertically, do you see, by the time you get to sort of a here, I don't want to draw it, aren't you not going from one shape to the other? Aren't you just going from one side of this curve to the other side of the same curve? What that tells me then is that I want this thing here to be rearranged in terms of x equals y squared, and rearrange this guy to be x equals y plus 56. Do you see I now have the limits of the x's? Now, what will the limits of the y's be? Well, won't they be from the -7 to the +8? Does that make sense from this information, how I came up with those limits of integration? Right. So if you think about it, that guy is y equals x minus 56, right? And, or I should say, if you rearrange it, it's x equals y plus 56, right? And that guy there, right, is on the x equals y squared, and this guy is on the x equals y plus 56. So now that I've set up the limits of integration, it's pretty clear that we do the x's first. And then there's one mistake I could make. One of these goes in the top, right? And one of these goes in the bottom. And it does matter. If you switch the order, you get a negative answer where you should get a plus, or a plus answer where you should get a negative. So which of these two equations should go on the top?
So I got the answer before you did on the graph by just substituting y squared for the x in the top equation, which would have made y minus 7 or 8. And it occurs to me that you could put those in any order, top or bottom, bottom or top, depending on what the other one was. So if you, as long as they match x and y, it should come out the same, right?
I don't know. I'm not
Like
sure what you mean.
if you're doing the x integral first and then the y second, as long as
One of
they,
those better have numbers, and it better be the one that goes here.
true, but what I'm saying is you're
Are
asking,
you saying this could be written as y equals the square root of x?
what I'm saying is that the x numbers could be flipped either direction as long as the y numbers also match, right?
Oh, so if you switch this the wrong order, you just switch these to compensate.
Yeah, isn't that what that means? Would it matter?
But you would get the right answer. I would choose not to do it that way because to me it seems like you're making life a little bit harder than it needs to be. What I would do is I would say, okay, this is the horizontal one. The one furthest to the right is obviously bigger, so the big always goes on top, and the small goes on bottom. And that means I can then do that. Now, you're saying to me that if you switch these, as long as you switch those, everything is fine. Is that correct?
Yes, that's what I'm saying. Is that true?
And you are correct. That is true. To me, it just seems easier not to flip things if you don't need to. So I always go furthest to the right is the big guy, goes on the top,
Yes.
and the small guy goes there. And if you do that, then the other one just comes naturally, right? Small and big.
Right. But I'm saying that the only reason you know that is because you graphed it.
Yes.
But if I hadn't graphed it, I did it a different way. I would have to use the equation to determine the order.
Okay. Yes, I would suggest you always graph it using
Gotcha.
Desmos. Right. So now that we set this guy up, we are doing x's first. Great. So with respect to x, that guy is xy. It's going to be evaluated at y squared and at y plus 56. Then once that's done, we can integrate with respect to y after that. So it's going to be from -7 to 8. If you replace the x with this guy, you get y plus 56 times y. Take away, if you replace the x with this guy, take away that fella. We would distribute this, call that y cubed. So what would that be? Y squared plus 56y, take away y cubed, dy. And this is where I would stop. Would you agree that's pretty straightforward per rule and you'd get your answer? Any questions about SketchUp and Desmos? That way you've got a good idea what the region looks like. Are you comfortable why I went horizontal lines, which means x equals to x equals, rather than vertical? Are we good? I'll assume that means yes. I need to, I've lost my questions. I'm going to go back in. There we go. Let's do another one. I need to find a region. Okay, done that guy. Okay, how about this region here? It's a double integral of x squared plus 2y dA, and the region D is bounded by y equals x and y equals x cubed, and x is greater than or equal to 0. Evidently, that's important. Now, sometimes I don't need Desmos because the shapes are pretty straightforward. So would you agree that that is y equals x? No problems with that? If I sketched y equals x cubed, it would look like this. But because they said x equals 0, doesn't that make this the region D? Are you comfortable with that? Now, this guy here and this guy here happen to be 0. And if you do it in terms of x is 1. Also, if you do it in terms of y, it also happens to be 1. So I need to set up the x and the y. Okay, can I scan through this region using nothing but horizontal lines? Yes. Can I scan through this region using nothing but vertical lines? Yes. So in this case, couldn't I choose to do the x's or the y's? It wouldn't matter. They would both be equally good. So I'm going to do a vertical line. Now, if I'm scanning through the vertical lines, won't the x go from 0 to 1? Right? So that tells me x is going to go 0 and 1. Now, the top guy is y equals x, so that's the big one. And the fella below it is y equals x cubed. And that represents region D. Are we good? Because I can't see many faces right now. I can see Tessa. Good, I got one nod. I'm glad I've got one nod. And a thumbs up is good as well. I kind of need feedback. Otherwise, you know, I could be doing a whole load of nonsense and you don't understand it, but I can't tell you don't understand it because you're too polite to say you're talking a lot of nonsense there. Right, now, once I've set this up, the double integral would be the x's from 0 to 1, always the numbers go on the outside, and the inside would be from y equals.
It is still not sharing. You canceled the share.
Oh, I didn't. Thank you for telling me that. Thanks, Sally. I think it was Sally. Was that you that said that? Yeah, thank you, Sally. So
It was real hard to see before.
it was if it wasn't there. So the x's go from 0 to 1, always on the outside. The big guy goes in the top, right? The smaller guy goes in the bottom, and the function we're going to do it to is this guy. And then I hope we're comfortable with this one is a dy dx combination. You know, you could accidentally skip them. Now, the integral itself is not that horrendous. If you integrate this with respect to y, you get x squared y. Integrate this with respect to y, you get y squared. And then you're going to evaluate it at y equals x cubed to y equals x. And when you're finished, then you can integrate with x's. You plug in x, you get x cubed. You plug in x, you get x squared. You plug in y cubed. What do you get? Y cubed, and that's an x to the 5. You plug in y cubed and square it, you get an x to the 6. Yes, that's what you get there. And then you're left with an x cubed plus an x squared. Take away an x to the 5, take away an x to the 6, dx. And I'll stop there. You agree with me? It's just a power rule. Probably a ridiculously ugly fraction, but nonetheless a power rule. In case any of you are wondering how to get an exact value, how to avoid decimals, let's just pretend that this ugly thing ended up being 1/4, take away 5/3, add a 7th, right? Just for argument's sake, right? Well, you type it in just like that, you hit enter. You then go to the math button, choose option 1, which basically says turn the answer into a fraction, and there's your answer, -10784. Can you see that it's pretty easy to do horrible fraction calculations on your calculator? Much nicer than trying to do it by hand. Yes, Al.
Yeah, and I'll also make a note for people who use a Casio calculator. There's actually a button that will just automatically turn a decimal to a fraction. I'm not sure if this is like a depending on the model of calculator thing, but they do make it an improper fraction, so you will have to convert it to I mean, not an improper fraction, a mixed number, so you'll have to convert the mixed number to the improper fraction. So like, for example, you'll get like 1 2/3.
So you need to write all fractions as improper fractions rather than mixed. So this is mixed, and you in America call them improper. I don't mind the name mixed fraction. I don't like the word improper fraction. It sounds like there's something wrong with it, right? It's just as good a fraction as others. I much prefer what we call it back home in Scotland. I like this name. Those fractions are called top-heavy fractions. I mean, doesn't that name make more sense if you think about it? Right? Top-heavy, bigger on the top, right? I like that name. So I very often call them top-heavy. So if you ever hear me say that phrase, now you know what I'm talking about, right? I'm talking about 5/3. How good are we with these types of questions? Are you feeling comfortable?
I was gonna
Yes.
ask, so I noticed for the y equals x, for like when you did your limits of integration, you made the y's x cubed to x. But you're saying that it was like the smallest one to the biggest one. Were you just referring to like when you just have like numbers?
Well, yeah. If you look at this one rectangle that represents all the rectangles you would scan through, isn't the straight line y equals x the big answer? It's further up. And isn't this the curve? And this one here, right, which is x cubed. Do you see that's the smaller of the two? So when you set up your limits integration, it's always the smaller thing to the bigger thing. Even if it's numbers, it's more obvious. But when it's an expression, it's this one is the lower down one, right? And this is the upper one. And if you accidentally switch them, you will get a negative answer when you should have got a positive answer, or you'll get a positive answer when you should have got a negative one.
Oh, would it be the same number, just positive or negative? So if you do end up flipping your
so if the answer was 4/3,
whatever sign. So like if you have like a positive, make it a negative. If you have a negative, make it a positive.
Yeah, that would be the fix. If you suddenly said, oops, I got them the wrong way around, I don't want to do the whole integral, the fix is it'd be the opposite sign of the answer you got. So the 17/3 will be the same, but the other isn't. What you got for me, Rosie?
Okay, so I think just to summarize what you were saying, you're moving left from right from 0 to 1. And so
from x equals 0 to 1. Yeah.
Okay, so then the y equals x cubed is smaller because it's below it, and you're moving vertically from left to right, correct?
Well, yeah, I'm doing vertical rectangles from left to right.
Okay, I see it. That makes sense. Thanks for explaining that again, Sally and Professor Robertson.
You're welcome. I'm sure Sally would say the same.
So I got a question, Professor. If this works for a linear and a non-linear intersection, technically, if both of those functions were nonlinear, it would still work, correct?
Yeah, I mean, can you imagine the function was some kind of quadratic that looked like this, and the other was a different quadratic that looked like that? This would be the top one, this would be the bottom one, and I'd still be doing my scanning, right, vertically from left to right. So can you imagine that was, say, x equals 1 was here and x equals 7 was here? Oops. So my integral would go from x equals 1 to x equals 7. And my y values would be whatever this guy is and that guy. This is the lower one, right?
Correct.
And I'm calling this one the upper one. So this is F and that's G. So that's how you would scan it. Now, sometimes you have to scan horizontally like we did with the first one. Now, doesn't that basically things just switch places? The y goes from this number to that number and the x's go from some function of y to another function of y.
So using this method, I remember when we did area between the curves, and it was a little bit more complicated than this.
Yeah, it's
Technically-
essentially the same idea, but with two variables instead of one.
Right, so why couldn't we use this instead of the original method and just take a slice and call it area between the two curves?
Oh, because if you took this to the end, all you're finding is the area of this region. But remember, there's another variable, which is a surface above it, and we're trying to
Right.
find the volume of that. So you
Right,
need
right.
to, yeah.
But if
So-
if there was a way to slice it, then we could. So that's what we're actually doing in Calc 2, right? We're actually taking a slice out of this.
Yeah, you're taking a slice and then imagine it going vertically upwards and adding them all up if you wanted to think of it as a Riemann sum.
Yeah.
Yes. Let's see if I can find another one. Oh, a cool one. This one falls under the category of puzzles because it doesn't really have the same kind of information that the others had. So imagine that I had a function xy, and the guy that we're trying to do is a triangle, and the triangle has coordinates 1, 1, 4, 1, and 1, 2. So the region D is the triangle formed by these particular guys. So I would go and I'd do a little sketch, 1, 1. And then I'd go 2, 3, 4, 1. And then I'd do 1, 2. So the region that they're talking about is this triangle. And we have got to set up the x's and y's that would generate this triangle. Now, some questions you can do vertical rectangles scanning from left to right. Some questions you have to do horizontal rectangles going bottom to top, right? And some questions you can do it either way, right? In some situations, either direction works equally fine. Me personally, I like to do vertical if it's at all possible because it tends to be nicer calculations. So can you imagine my vertical rectangle would look like that? Now, if my vertical triangle looks like that, won't I be scanning from left to right this way? So I'd be scanning from x equals 1 to x equals 4. So far, so good, right? My first rectangle would be at x equals 1. As I scan along my little slices, my last rectangle would be at 4. So that's those guys. Now, how about this rectangle in terms of what its y values are? So I need to find out what that guy is, and I need to find out what that guy is. Would you agree that the bottom of this rectangle for this particular shape, isn't it always 1?
Yeah,
So,
and then it won't go up to 2.
but it won't necessarily go up to 2 except at the beginning. Won't it be at different heights depending on where the slice is? So won't this height be the point on this diagonal line? So doesn't that mean I have to find what the equation of that line is to figure out this guy? So that's kind of the difference here. We have to do some extra work. Now, if I put in some points to help us here, that point there has coordinates 1, 2, and this point here has coordinates 4, 1. Shouldn't we be able to find the equation of the line that makes the top of where my rectangle would go?
Yeah, it's going to be a slope equation, right?
Yeah. So if we do a quick slope of rise over run, would you agree it's a rise of what, 1 and a run of 3? Is it okay doing that in my head? 1 box by 3. Can you kind of see it? Right. I now know the slope. If I choose the point with coordinates 1, 2, that one, call it P, can't I use the y minus y1 formula that you haven't used for ages to get the equation of that line? If I add 2 to both sides, I get, I believe, plus 5/3. So I now know This guy is 1/3 x plus 5/3. So I've now set up the limits of integration for that region D.
Would it just be 1 since the 1/3 in the x? Wouldn't that, because that's negative 1/3? So when you add, oh wait, derp, it's 6/3.
Yeah.
I can't multiply.
That's okay, I can't add, so we make a great pair, right? So we got this guy. Are you comfortable about the integration limits that have now been set up? Because once you've got them, your question is ready to go. Because all you do is you put the pieces together and you are going to do a double integral. The numbers always go on the outside, so x is going to go from 1 to 4, and the y's go from the small guy, the bottom of the rectangle, which is 1, up to the top of the rectangle, which is on this line, and this line happens to have that equation. And then whatever z is goes here. And in this case, it's going to be a dy first and finishing the dx afterwards. I'll take this just a little bit further. xy, if you integrate it with respect to y, gets you 1/2 x y squared, evaluated at 1 and at 1/3 x plus 5/3. So that's going to be the integral from 1 to 4. If you replace the y with this guy, you get 1/2 x, 1/3 x plus 5/3 squared. Take away, if you replace this by 1, you get take away 1/2 x. So you're now in Calc 2 world, where you're just trying to find a single integral with respect to x. I am going to stop here, but let's talk a little bit about what you would do in general. What would I do next to help me integrate this? Because I don't think it's a good idea to leave it the way it is.
I would FOIL out the, I would FOIL the 1/3 x plus 5/3,
Yeah.
and then I would distribute the 1/2 x.
Yeah, and you get some really ugly polynomial, wouldn't you? There wouldn't be anything nice about it, but it's doable. And then won't it just be a power rule with all, ugly fractions everywhere? But you know how to use your calculator to deal with fractions, and you'll get the answer 17 112ths or whatever it ends up being. Are we cool with how we tackled this question where the region wasn't even given to you directly, it was just given to you in the form of a triangular set of coordinates? Next one we're going to do is a different kind of puzzle. They mention the word volume. In this context, don't we always realize that a volume just means it's a double integral or something, right? So in this case, we're being asked to find the volume. The fancy phrase that they use is enclosed by, it's called a paraboloid. Now I've written it, I'll put it down. And the paraboloid is z equals x squared plus y squared plus 1. If you're wondering what a paraboloid is, it's one of those guys that looks like an acorn. Yeah, that's what paraboloids look like, right? Big bowl-shaped objects. Now, here is the restrictions. X has to be 0. Y has to be 0. Z has to be 0. And x plus y has to be 7. Right. The z equals 0 is not a big issue because that just means it's on the floor. So I'm not really paying too much attention. These two guys I am. If you do the line x plus y equals 7, I could definitely do this in Desmos, but it's pretty easy to do, by hand, right? That's what x plus y equals 7 looks like. Now, since x is 0 and y is 0, doesn't that restriction tell me that's the triangle we're stuck with? So far, so good. That there is region D. Can I do this question with vertical rectangles scanning from left to right? Could I do this question with horizontal rectangles scanning from bottom to top? Could I do this region in both those ways? Agree? Which direction do you want me to do? Do you want me to do vertical ones from left to right, or do you want to see what it looks like if you do horizontal lines from bottom to top? Which way do you want me to? Both work, both are correct.
Horizontal.
Let's do horizontal. We haven't
Yeah,
done
let's do
that.
I haven't done many horizontals. So I'm just going to pick a random horizontal, right? There. But essentially, aren't I scanning from bottom to top? Now, since I'm scanning from bottom to top, that tells me that the Y values are going to be at 0 when I'm here, and up here it's going to be 7. If I'm looking then at the beginning and end of this rectangle, it's going to be at this side, isn't the X coordinate always going to be 0? And at this side, isn't the X going to be 7 take away Y? Didn't I just rearrange X plus Y to be that one? So the small guy is here and the big guy is here. Are you happy about how I got the limits of integration for that region now? Now, if I decide to do this, which we have, then we're going to take our double integral. The function is x squared plus y squared plus 1. And the numbers are the y's, so y equals 0 to y equals 7. And the other guy is from x equals 0 to x equals 7 take away y. And won't that mean you do the y's before you do the x's? Are you happy about how we set up this double integral now?
You mean we do the part
Oh, yeah,
the
yeah.
integral with respect to x, and then we do
Did
the
you
integral
all
with
catch?
respect to y?
Yeah. Did you all catch that deliberate mistake? You do the x's before the y's. And this is going to be the volume that we're after. In this case, then, I don't think I'll take it much further. If you integrate with respect to x, you get 1/3 x cubed plus y squared x plus an x. You then evaluate it from 0 to 7 take away y. And when you're finished with that, you integrate with y. Maybe one more line. So it's going to be the integral from 0 to 7. This thing's going to be 1/3 7 take away y cubed plus y squared 7 take away y plus a 7 take away y minus a whole load of zeros. Isn't that equation just time consuming? Couldn't you just FOIL the whole damn thing out and get a polynomial? That's how I would tackle it. Be really ugly, but doable. Got time? Yeah, we got time for this last guy here. Here is a double integral where everything is set up for you. And you're not even being asked, I don't believe so anyway. Yeah, you're not even being asked to find it. What you're being asked instead is to find out what the region D would look like and try and draw what the solid that this is a volume for is. So it's like taking things totally back to front and upside down. So if you tell me these two limits of integration, you're telling me that x goes from 0 to 7, and you're telling me that y goes from 7 minus x to 0, I should be able to draw this region on my two-dimensional paper, right? of all the numbers that are here, or all the terms that are here, isn't the 7 minus x with the y the most useful? Because won't that be generating a line called 7 minus x? Great. Now, y equals 0, x equals 0 to 7. If you put all of that together, do you agree that that's this triangle? So if I see a double integral, shouldn't I, with a bit of work, be able to figure out what the region D looks like? In this case, it's this guy here. Now the harder part. That guy. Because now we're going to try and figure out, what does the 3D region look like? Well, isn't that guy your Z? Great. That's your Z. Now, it's not that often, because it's so ugly and so hard to do, that you draw a sketch of a 3D shape. I'm going to try. If the x coordinate is 0 and the y coordinate is 0, won't the z value be 7? So doesn't that mean that this shape crosses the z-axis at 7? Are you with me? Now let's find out where it crosses the y-axis. Doesn't it cross the y-axis when, so that's where it basically crosses z-axis. Right, let's find out where it crosses the y-axis. Well, when it crosses the y-axis, isn't the x equal to 0 and the z equal to 0, right? And now if you make x equals 0 and you make z equals 0, doesn't y become 7? So that would be there. And same argument, it's 7 over there. If I draw those guys together, can you see the triangular plane that would be? And on the floor, do you see our region? So the volume that you are calculating here, isn't it the volume of a little, oh, you ever seen one of those funny little dices that only have 4 sides to them? Kind of looks like that.
A D4.
A D4. It's basically a D4, if you know what a D4 looks like. Couldn't it look like a very strange pyramid, where the pyramid's not got the point in the center? Actually, that would probably be a very difficult pyramid to build. Structurally, it's kind of lopsided. Isn't there a tendency that it might want to fall over if there was a strong wind? Right, but that's what that shape would be. So this is an example of what's happening in question 11.
So it's a triangular pyramid that had a little earthquake damage.
Yeah, but that'll work. Or it's somebody who likes playing D&D and they're used to all sorts of different dices or dice. Right, perfect timing, even a little bit over. Sorry for keeping you 3 minutes beyond your time. I know it's important. Last name and bye-bye. And I can hang about for a few moments, but